Students, now page number 9. So this graph shows how electric field changes with the distance r from the source charge q. So suppose here is a charge q and this is a distance r and this is a point p. For example, this is 6 Newton per coulomb. If the point is here, the distance is more, let it be 4 Newton per coulomb. If the point is here, the distance r is more. Now maybe here it is 1 Newton per coulomb. So in that manner, as the distance increases, the electric field at the point also decreases. So this graph shows that as r value, this is r along the x-axis, electric field at that point is E. As r increases, electric field gradually decreases. In a small distance r, there is a high value of electric field, and r increases, electric field increases in a proportionality, that is inverse square proportionality, inversely proportional to square of the distance. Now, electric field due to a system of charges. Imagine there is a system of charges in space consisting of 4 charges. We are taking 4 charges only, q1, q2, q3 and q4. So these are the 4 charges in space, q1, q2, q3 and q4. They are at distances r10, r20, r30 and r40. So their distance to a point O is given as these different distances. Then the net electric field at O is the vector sum of individual electric fields. So due to Q1 there is an electric field here, it is denoted as E1. Due to Q2 the electric field here is E2. Due to Q3 the electric field here is E3, and due to Q4 the electric field here is E4. So the net electric field at O is, we can write it as, the net electric field is E1 plus E2 plus E3 plus E4. We have to add all of them vectorically. Anyway, we can write it in the same thing in equation form as, we can take the common factor, that constant 1 by 4 pi epsilon 0 out, and these terms represents the remaining terms in the each term. The same thing we can write in a sigma notation, that is final electric field at O is vector E equal to 1 by 4 pi epsilon 0 sigma I is changing from 1 to n qi divided by ri0 square into r cap i0. Now, physical significance of electric field. The first one is, electric field explains the electrical environment of a system of charges. Whether the field is uniform field, whether there is an field is rising, field is falling, it is a continuous field, like that idea we will get. The second thing is, vector E at a point in space help us to explain interaction between two charges. So if we know the electric field nature, suppose we are placing a charge, we can even predict that how force is going to act on that new charge, on that existing electric field.